Today we're going to learn about synthetic division of polynomials. This works similar to our long division. It does the same thing, but it's a little simpler of a process and it's kind of a nice shortcut to use instead of having to do long division every single time. So when we're using synthetic division, we want to check to make sure that our polynomials are in standard form. We would still want to fill in zeros for any missing terms, just like we did with long division. And then we're going to still write our answer. If we have a remainder, it's going to go in a fraction over that divisor. So writing the answer, setting up the problem is very similar, but it'll look a little different for that solving process. The other difference here with synthetic division is it only works if our divisor is in that form x minus r. So we have to have that leading coefficient here of 1 in front of x, cannot be any exponent on x, and then we're just adding or subtracting a constant. So x plus or minus a number there has to be that form in order to use synthetic division. Okay, so I went ahead and am showing this first problem with long division, and I just want to have the synthetic division right next to it so you can kind of see the comparisons. So what we're going to do is we're going to take this x minus 4, our divisor, and we're going to solve for x. So I'm going to take x minus 4, set it equal to 0, and we're going to make sure we get x by itself. So the number I'm going to use in synthetic division is 4. This is where it starts to look a little weird, but follow along. So I'm going to put 4 here, and I'm going to draw a line. Okay. Now, I only want to take my leading coefficient, or not leading, my coefficients in front of each number here, and that constant in front of each variable, and we're not going to have any of the x's or any of the variables in the synthetic division part. So the 1 will come down, the negative 2, the negative 22, and the 40. Okay? So we're just dealing with the coefficients in synthetic division. Okay, the first thing we're going to do is we're going to drop down that first coefficient of 1. Then we are going to multiply the 4, the divisor, times the 1. So 4 times 1, I get 4, and that's going to go underneath my second coefficient. We're going to add straight down these columns. I get 2. And now I'm going to repeat that same process. I'm going to take my divisor 4, my 2, we're going to multiply those. I get 8. So that's going to go underneath the next coefficient. When we add negative 22 plus 8, we get negative 14. And we repeat our process again. The 4 times the negative 14, I am getting negative 56. And then we add straight down our column. Okay. The number very last here is always going to be your remainder. Okay. Okay, so if we were to compare this with our long division, we can see that each time when we subtract, let me get my, okay. So each time that I do my subtraction, so right here, I get a remainder of the 2. Well, that lines up here. When I do my subtraction here, I get a remainder of the negative 14. That falls here. I do my next subtraction, I get that remainder of negative 16. That ends up here. So we can see where all the numbers are coming from. It's the same process, but once you get the hang of synthetic division, it's going to be a lot simpler and quicker than your long division, but they will both still work. So now we got to figure out how to write our actual final answer here. So if I know that this negative 16 is my remainder, we're not going to deal with that until the end. But the way I kind of remember how to start with putting the x terms back in with these coefficients is we started with x to the third power and we divided by an x term. So we should have an x squared term. The thing I remember here is it's always going to be 1 less than your original exponent. So I'm going to start with this becomes 1x squared this becomes plus 2x, and this we just bring down as a minus 14. Okay, standard form, working our way down, largest exponent from there. Then I have a minus 16, but remember we always are writing that remainder over our divisor, so x minus 4 back to that original divisor. Okay, we got the same thing over here when we did long division. We had x squared plus 2x minus 14 with our remainder of that negative 16. Okay. Okay, so let's keep trying this, just get some more practice. So I take my x plus 8, set it equal to 0, and we solve. I'm going to use negative 8 for my synthetic division. And we are just taking our coefficients, not the actual x terms. So I have a 1x cubed, I have a 5x squared, I have a negative 20x, and I have a 32. First coefficient gets brought down. We multiply the negative 8 and the 1 and put that underneath the next coefficient. And then we add straight down. So 5 plus negative 8, I'm going to get negative 3. And I'm ready to multiply the negative 3 and the negative 8. I get positive 24. That goes underneath our next coefficient. We're going to add straight down this column. Negative 20 plus 24, I'm getting 4. And we're repeating our process. We have the negative 8 times the 4, and I get negative 32. Very last step, add straight down that last column, and we get 0. Remember, this is our remainder. So now that our remainder is 0, we don't really need to do anything with that. We can just write our final answer, our final polynomial here. So my original exponent was 3. We divided by an exponent of 1. So I'm going to have 1 less. So I'll have x squared. I'll have negative 3x. And I'll have plus 4. No remainder, so we don't need to write plus 0 over x plus 8. Only if you actually have a remainder do you need to do that. Okay, let's keep trying some. One thing I want to point out, let me get some of this out of our way. One thing I want to point out on this next one is we have 5, we have 3, we have 4, we have an exponent of 1 and a constant. We need to make sure that these are in order in our standard form with the largest exponent first and decreasing exponents from there. So the first thing I want to do is rewrite my problem so I don't make any mistakes when setting it up. So my largest exponent is x to the 5th. My next one would be the negative 5x to the 4th. Then I would have plus 6x cubed. Now I don't have an x squared term, but I want to go ahead and fill in 0x squared so I don't forget to use that in my setup, in my synthetic division. Then we have our x term and then our constant. Okay, so this is the polynomial I want to use to set up my synthetic division. I'm going to go ahead and solve my divisor here to get the number to use with our synthetic division, and I'm going to use 3. Okay, so I'm taking the coefficients. I have 1 in front of x to the 5th. I have negative 5 in front of x to the 4th. 6 in front of x cubed. 0 in front of x squared. 5 in front of x. And negative 15 as the constant. You have to remember to put that 0 in place of your x squared term. Okay. Okay, let's start our process. I'm going to bring down my first coefficient of 1. We're multiplying 3 times 1, I get 3. And then we add straight down that column. All right, keep going here. I'm going to multiply 3 times negative 2. I get negative 6. And we add straight down that column. And we keep going. 3 times 0, we get 0. I'm going to add straight down that column to get 0. Then we have 3 times 0. I get 0 again. We add straight down, we get 5. And then I'm multiplying 3 times 5 to get 15. We add straight down, and we have a remainder of 0. So remember that very last term there is always your remainder. And now I'm going to go ahead and set up my polynomial answer with what I have left over without that remainder. So this time I started with a largest exponent of 5. So when we divided by an exponent of 1, we went from 5 to 4. So my first term here is going to actually represent x to the 4th. And then we work our way down. Minus 2x cubed. We don't need to write either of these because it's just not representing any terms for the x squared term or the x term. So I'm going to go right into my plus 5 for the constant. No remainder, so we don't have to worry about writing that in. So this one gets a little more complicated, just making sure you have that 0 in front of your x squared term, and then you keep going with your synthetic division with that 0 in place there. Okay, number 4. On this one, we just have x cubed minus 27. So we're going to have a few 0 terms in here because we don't have the x squared term represented and we don't have the x term represented. So I'm going to have my divisor. I get 3. So I'm going to set up my synthetic division with 3. I have a 1 in front of the x cubed. Oh, I just want the 1, just want the coefficient. We don't have an x squared term, so I'm going to put a 0. We don't have an x term, so I'm going to put a 0. And then we're finally ready for that constant, so I write that negative 27. Okay. Bring down our first coefficient, 1. 3 times 1, I get 3. Add straight down, I'm going to get 3. Then multiply 3 times 3, I get 9. Add straight down, I get 9. And 3 times 9, I get 27. Add straight down, I get 0. And we know that 0 represents our remainder. I started with x cubed. I divided by an x term, so it decreases by 1. I have x squared plus 3x plus 9. Okay. Okay, and then just to make sure we kind of understand where all this stuff is coming from, what this tells us, let's look back at number 4. If I take x minus 3 and multiply it by x squared plus 3x plus 9, it will give me the answer, x cubed minus 27. Okay, so basically what we're dividing by times what we get is going to give us our final answer polynomial. Okay, making sure we understand that concept of what we have left over. If you multiplied that times your divisor, you would get your original polynomial. Okay, a couple other things here that we can do with our remainders to understand our polynomials. So it says our factor and remainder theorem. So if we substitute our solution to the linear expression, so every time we've been solving up here that x minus 3 equals 0, our solution would be that x equals 3. So if we substitute that solution into the linear expression, or into the original polynomial, if the result is 0, then we know that that expression is a factor of the polynomial. If we substitute that value in, and the result is anything other than 0, then we know that that expression is not a factor. Okay? So we'll get some practice with that, but we just want to take our expression, plug it into our polynomial, and then look at what our remainder is. So I'm going to start here on this first one. If I have x minus 5, I'm going to take x minus 5, set it equal to 0, and we're going to solve. So now I'm taking this solution, x minus 5, and we're going to go substitute it into the polynomial, our original polynomial. So I have 2 times 5 cubed plus 7 times 5 squared plus 2 times 5 plus 1. And we can just type that into our calculator all at the same time, and I am getting 436. So if we look back up here to what I highlighted, if the result is 0, then the expression is a factor. If the result is something other than 0, then it's not a factor. So since this is not 0, that means 5 is not a factor. Okay? Since it's not 0, we know 5 is not a factor. All right, let's go and try this with our last example here. So I have my polynomial x cubed minus 13x minus 12. We are dividing by x plus 3. So I'm going to take my x plus 3, set it equal to 0, solve to get our solution. We have our solution and we're ready to plug it into our original polynomial. So I have, instead of x cubed, I have negative 3 cubed, minus 13x, so minus 13 times negative 3, and then minus 12. When I type that in, I get 0. So again, going back up here, if the result is 0, then that linear expression is a factor. Okay? So we'd say, since it's 0, so negative 3 is a factor. Okay? Meaning x plus 3 is a factor of that polynomial. All right, that is all.